A major part of your SAC will be analysing some bivariate data, and here we've got a scatter plot, so numerical v numerical. Okay, so let's have a look at this question here and work through a full regression analysis is what we're going to do. Alright, so first of all, having a look at our data here and what we're looking at or analysing, male life expectancy and female life expectancy. Okay, 2013 is when the data's from. So a couple of things to note. Female life expectancy is the EV. That means that male life expectancy is the RV, or the response variable. Let's just write this down on the table so that we're clear on it. Our female life expectancy is the EV, male life expectancy is the RV. So the table's written in the opposite form to what we're maybe used to a bit. We're used to seeing the X and the Y, or the explanatory and the response, in that order. But what they'll do quite often in an exam or a SAC is just order the columns differently. So you're just going to be good enough to know that we've got RV here and the EV here. Right, so let's answer some of these questions here. So the explanatory variable is the female life expectancy, and therefore this is the male life expectancy. And what association we've got here? Well, look, it's pretty strong. Okay, in fact, I reckon it will produce an R value of 0.9, so something really high. It's going up and to the right, so bottom left to top right. So what we've got is strong, positive, linear association. Okay, and when you describe the association, make sure you use those three words: strong or moderate, negative, and linear, if it is indeed that particular type of association. Alright, so now what we want is the regression equation, and regression equations are written in the form y equals mx plus c, or y equals c plus mx. Alright, so what we're going to do is make sure that when we write the regression equation, it's the equation for this data here. Okay, so we do that and we show that it's for this data here by really contextualizing our equation. Alright, the y value in this form here is the response variable, which is male life expectancy, and that is equal to, alright, now we need the gradient and the y-intercept, and that's fairly easy to get with the TI calc. And I've already typed in the data here. Male data is in this column here, female data is in this column here, so I've just given them column headings: MA for male, FE for female. Alright, so what we're going to do is run some statistical analysis on this. We'll go menu, 4, 1, and either 3 or 4, depending on the form you like your regression equation in. I like 3. Okay, the X list is the explanatory variable. So our explanatory variable, as labelled here, was the female life expectancy. This will be the male life expectancy. And let's just put the results in column B. We'll put them in column C. Okay, and that'll be the next column over from the data. Alright, so here it is. We've got an M there and a B there. Okay, so write the regression equation, and let's go to 3 sig figs. Your exam or SAC will tell you the rounding that you're after. Alright, so the M is the first value that we're after. Okay, so in 3 sig figs, that's 0.808. Okay, first, second, and third sig fig. So 0.0808 multiplied by X, and that is the explanatory variable, female life expectancy. And then the B value, which is a positive value, so plus 3 sig figs is 9.69. Okay, so there's our regression equation put into context. Alright, now what we're going to do is draw this equation here onto the scatter plot. And for any permutation equation, this is the approach that you use. Okay, what we're going to do is go up to the scatter plot and have a good look at it. We're going to choose 2 X values to base our Y values, or response variable values, on. Okay, and VCAR, and I agree with them, they recommend choosing points on either end of the the axes that you're given. Okay, so we're going to go 60 and 85. You could use 55 and 90, but I'm worried that if I use 55 it might be down below there, which means I can't plot it. So I'm just going to make sure I choose something that I definitely can plot. So I just go usually one in from either end, so 60 and 85. 60 and we want the y value, and 85 and we want the y value. Alright, pretty easy to get with an equation. All we do is go over to the calc and we go control and dock to insert a calculator. We just use this regression equation here to pump out the values. So this will give us the male life expectancy for any female life expectancy. So we want it for these two values here. So we're going to go 0.808 multiplied by 60, which is the female life expectancy, plus 9.69, and note that value. Alright, and it's 58.17. So let's write it down, 58.17. Right, let's do the same for 85. Back over to the calc, hit enter on that line there to copy it down, and type in 85 instead of 60 this time. 78.37. Alright, going to plot those points now. Alright, so when x is 60, y is 58.17. There's 55, 56, 57, 58. So round about there. Okay, it just happens to be on a point. That just is luck. So don't think you have to line up with a point. In fact, most times it probably won't. Let's see what happens with 78.37. So 85, 78. So there's 75, 76, 77, 78. So we're around about here. Again, that's just sort of flat out luck that that's fallen directly on a point. Alright, so what you're going to do is join that dot and that dot there with a line. I'm going to try and do this with a stylus pen, and it's a little bit tricky to do, but let's give it a go anyway. So I don't know which direction this is going to go. Ugh. No, it's a bit off. Oh, that's alright. Alright, we'll take that. Alright, extend your line out as far as it'll go in either direction. Now that's going to be a bit off what you get. I'm trying to do this on a stylus and I can't really see what I'm doing. I reckon it's going to be a little bit higher, like somewhere there. Okay, so just be a little careful of this. Alright, so there's our regression line. Don't have to label it or anything like that, but there it is there. So, draw the least squares regression line on the scatter plot. That's done. Right, what's the value of Pearson's correlation coefficient? Let's grab that to, say, 2 places. Right, again, let's go back to the calc and have a look at the R value, which in this case to 2 decimal places is 0.95. Okay, so 0.95. Interpret the R squared value. Okay, well R squared is also given to us, that's 0.9017. 0.9017. Now when we interpret it, what we do is we convert that to a percentage. Alright, so we're going to multiply this by 100, and that is 90.17%. Okay? Alright, so the way we interpret it is we say 90.17% of, and this is basically a script that you can just regurgitate out. Okay, it comes up all the time. 90.17% of the variation in, okay, and it's always the response variable that we quote now. So the response variable is male life expectancy. Can be, scroll down a bit here, be explained by variation in female life expectancy. So here you always put the response variable, here you put the explanatory variable, And it's really important that we mention the words variation twice, okay, because it's variation in the explanatory variable that causes this variation, or that not causes, I really shouldn't use that word, is variation in the female life expectancy that that suggests changes in the male life expectancy. Okay, we can't use causes in statistics. Alright, so generate a residual plot to test the linearity assumption and write your conclusion. Okay, so what we're going to do is put this into a scatter plot. Now I'm a little rusty on this because I'm used to a class pad, but let's give it a go anyway. I'm going to go Control and Doc and go Data and Statistics. Alright, and I'm going to pull up the scatter plot. So this is the explanatory variable here, which was female life expectancy. Let's chuck in the male life expectancy over there. Alright, so now what I'm going to do is generate the residual plot. So we go Menu, and plot type, plot properties, action, analyze. Alright, analyze is the one we want. And what we want to do is, we want the residuals and it's not there. Okay, why isn't it going for us? Let's try it again. So menu, analyze. Why isn't it going to give us the residual plot? Alright, I'm going to pause this for a second. Alright, we're back on here, and yeah, the reason it's not going to produce residuals, of course, and I've got to think about this, is we haven't done regression or shown the linear regression line yet. Okay, the residuals is basically how far off the prediction is from the actual. Okay, and so what we want to do is show the linear. Alright, now that we've got the line in here, or the least squares regression line, if I go back into menu and analyze again, lo and behold, residuals is up. So let's just check out the residual plot. And what we're looking for, if it is a good linear model, is we're looking for a bit of chaos here. Let's check it out. Alright, so it does look pretty chaotic. I can't really form a pattern out of this. So it really does. Okay. So what we say is something to this effect: the random scatter of the points, or lack of pattern on the residual plot suggests the data is linear. Okay, now we're going to grab the residual value for a country that had a female life expectancy of 73. Alright, so to answer this question here, the first thing we're going to get is the actual. Okay, so 73 was female life expectancy. We want to know what the male result was. Let's go up here and find that data point. Alright, so when female was 73. So I'm looking through the list here, and this is the one. Alright, so 73 produced a male life expectancy of 69. 73, 69. Alright, and now what we're going to get is the predicted. Okay, so when female life expectancy was 73, we want to make the prediction. Okay. Alright, so let's go over to our calculator, and we can probably just go back to the calculator screen here where we did this stuff here. Hit enter on this. We use this to work out, or to get the regression line, but we can also use it to find predicted values for any values along the explanatory variable. So let's go 73, and that is 68.674. Okay, so what we're interested in here is, was this value, or how far off the predicted was the actual? Okay, so the actual was higher than the predicted. Okay, so what I know is this will produce a positive residual. That leads me to, to I don't really need to memorize the formula. I know this residual is going to be positive, so I know the formula for the residuals is the actual take predicted. Okay, because I know that it's going to produce a positive residual. Okay, we need 69 take away 68.674, and that will be, let's go over to the calculator because I'm bad with my decimals, 69 take away 68.674 actual take predicted gives us a residual of 0.326. Alright, and last question here. Another country was added to the data set. Female life expectancy is 65, male life expectancy of 75. Alright, and what we're interested in here, will the new value increase or decrease the gradient of the regression equation? Explain. So, well, let's just plot that point and see. 65, 75. 65, 75. Wow. Okay, so that is an unusual data point there. Okay, and almost you could say is a bit of an outlier. Now, the problem with Pearson's correlation coefficient and this regression line is that it's severely affected by outliers. This is going to really wreak some havoc on the Pearson value as well as the regression line. And what this point will actually do is yank this line upwards. Okay, it's going to pull it towards that point there, because this will affect the means, okay, on both ends, okay, and yeah, the tendency is that is going to grab it and pull it upwards, okay. So if it pulls this line upwards, what is going to happen is the slope is going to decrease, okay. For every value of x increasing, the y value isn't going to increase as fast, okay. So let's see if we can go and answer that question. Will the new value increase or decrease the gradient of the regression equation? Explain. It will decrease the gradient. And the reason being, the new point is an outlier. Well, probably should say possibly an outlier, and will, let's say, pull the regression line toward it, therefore decreasing the slope. Alright, just to show you what it will do, let's go back to our data and actually pop in the point. Okay, now remember we had very strong positive linear. Okay, and I'm going to put female life expectancy is 65, male life expectancy is 75, and have a look straight away. So it's reduced the R value, not by a lot, okay, it's down to 0.84, okay, from 9. Let's make a crazier outlier. Alright, let's just say that a country with female life expectancy is 65 had a male life expectancy of 20. Alright, what we will notice out of this is the regression, or the R value, is going to decrease a lot more, and one outlier goes from strong positive, very strong positive, to moderate. Okay, alright, so there's a full regression analysis, okay, and again, expect something similar to that, but that covers a lot of different sort of things that you'll be expected to do in the SAC or the exam.